Welcome to solverfy.
Chapter 1, Section 3, Problem 10. Question. The following conversations frequently occur in physics and are very useful. A. 1 mile is equal to 5,280 feet. And 1 hour is equal to 3,600 seconds. And so our first task for part A of this problem is to convert 60 miles per hour into feet per second. Okay, and so the one thing to recognize is to maintain our units and correct numerical values, we are only allowed to multiply by 1. And what that means is we can divide these quantities by each other and they remain the same. So an example, just looking at the hours, if we have 1 hour divided by 360 seconds is equal to 1. And we can get from here to here by dividing by one of the other units. And basically the reciprocal is also true. So 3,600 seconds divided by 1 hour is equal to 1. So this quantity we want to divide by 1. And the way we find out which quantity we want on the top or bottom depends on which quantity we want to get rid of. So we want to get rid of this hour. So we put hour on top. 1 hour per second. And so what we want to do is convert the units of hours to second. We could have also started off with miles, but in the end, it doesn't matter. And so for every hour, we have 3,600 seconds. So we multiply this by 1, as this is equal to 1. And so now we want to get rid of this mile quantity. And so we do the same with the mile. And so we put, since mile's on top, we put mile on the bottom. So for every mile, there are 5,280 feet. Okay, and so now in terms of units, we can cross things off. So the unit of miles goes away, the units of hour can go away, and we're left with 60 divided by 3,600 times 5,280. And this will be, if we plug it into our calculator, this is equal to about 88 feet per second. Nice. And so on to the next part. If we continue to read, it says the acceleration of a free falling object is about 32 feet per second squared. And they ask us to use the quantity that in 1 feet there are about 30.48 centimeters. And so what they want us to convert to is meters per second squared. So all we got to do is just change from feet to meters. Okay, there's another step involved. So the quantity they give us goes from feet to centimeters, and we'll see in a little bit how we can deal with that. So from 32 feet per second squared, just like the previous problem, what do? We only multiply by 1. And so we want to get rid of this unit of feet. And so if we divide both of these by this quantity, we get 1 feet per 30.4 second, 34.8 centimeters is equal to 1. And or we could get the inverse where you get 1 is equal to 30.48 centimeters divided by 1 feet. And so since we kind of get rid of the feet that's on top, we put feet at the bottom. So there's 1 feet per 30.48 centimeters. Great, we got rid of the feet, right? But we have another problem. We have centimeters and our end goal's meters. So we need to have another conversion. And so luckily we could pull from our back pocket that we know for every 100 centimeters, it's equal to 1 meter. And so now we can cross these centimeters out. And so now we have our meters per second squared. So if we plug this into our calculator, we should get that this is approximately 9.75 meters per second squared. And so this is very, very close to the value that they normally make you use for acceleration when using SI units of 9.8 meters per second squared. Or it's a lot of times they'll round it off to 10 just to make the calculations easier. But it just depends whatever they ask of you and how accurate your calculations need to be. Okay, and so for the last part, part C, it says that the density of water is 1 gram per centimeter cubed. And they asked us to convert the units of this to kilogram per meter cubed. Okay, it's one thing that we have to realize is for every 1,000 grams, we have 1 kilogram. And for every 100 centimeters, we have 1 meter. And so this one's a little bit tricky because it's not asking for 1 centimeter, centimeters cubed. We'll show you how to deal with it. So we start off with our general quantity. And what do we do with the change of units? As mentioned before, we multiply by 1. And so in order to get rid of this grams, we got to look at this quantity. So we put grams on the bottom. We notice that there's 1,000 grams per every 1 kilogram. Great, so now we could get rid of these grams. And so next we want to get rid of the centimeter cubed. So the cube part we'll hold off for just a second. So first we recognize cubes on the bottom, so we want to put cube on top. Or centimeter, I'm sorry. Over 1 meter. And so the thing is, we have 3 centimeters cubed, but right here we only have 1. So we actually have to do is multiply this whole entire quantity by cubed. And so this 3 will get distributed to this 100 and this centimeter, giving us 1 million centimeters cubed per 1 cubed, which is just 1 meters cubed. And so we could technically cross off the centimeters cubed with all of these centimeters cubed, leaving us with 1 times 100 to the third, which is actually 1 million, divided by 1,000 grams. And we're left with kilograms per meters cubed. And 1 million divided by 1,000 just gives us 1,000. So it's 1,000 times 1. So the unit conversion of 1 gram per centimeter cubed is actually 1,000 kilograms per meter cubed. One thing that, just to put in quick perspective of how dense water and how heavy it is, 1 kilogram is about 2.2 pounds. So that means in 1 cubic meter of water, it's 2,000 pounds. So you could just imagine a 3 by 3 by 3 case of water. If it was just only filled with water, it would weigh a ton. Just an interesting little fact to throw in there. All right. Hope that was explanatory in itself. And I wish you all the best in your future endeavors of problem solving.